everyone, welcome to today's session. Many of the students face difficulties and problems in solving questions given at the end of each chapter in your ICSU Grade 10 Concise Physics textbook. So I am here with clear and helpful explanation to those questions given at the end of each chapter. We will begin with chapter 4, Refraction at Plane Surfaces. We will solve exercise 4a. Here we go. Question number 1. What do you understand by the refraction of light? As you know, you have to define the term refraction. Refraction is the change in path of the light when it passes from one transparent medium to another transparent medium. Give the correct definitions as given in your textbook. Okay, learn definitions. These definitions define type questions can be asked for the board examination carrying 1 or 2 marks. Question number 2. Draw diagram to show the refraction of light from air to glass and glass to air. In each diagram, label the incident ray, refracted ray, angle of incidence and angle of refraction. So we have to show the refraction from air to glass. First show the boundary between glass and air, and a ray of light incidenting the glass surface, ray of light PQ, that is the incident ray. Draw a normal, and angle between incident ray and the normal is angle of incidence. Now apply the rule of refraction. When a ray of light traveling from rarer medium to denser medium, it is bending towards the normal. Okay, that is the angle of refraction, and QR is the refracted ray. So I can write this is the incident ray, and this is the QR is the refracted ray. Okay, so we have marked all the terms given. Now in the second part we have to show the refraction from glass to air, that is from denser medium to rarer medium. So the incident ray is striking the glass air intersurface, and mark the angle of incidence. Draw the normal. Angle between incident ray, that is PQ, is angle of incidence. Now it is ready to emerge from denser medium to rarer medium. As you know, when a ray of light traveling from denser medium to rarer medium, it is bending away from the normal. So the angle of refraction. So PQ is the incident ray, QR is the refracted ray. So you can write PQ incident ray, QR refracted ray, and label the angle of incidence and angle of refraction correctly. Alright, so that part is over. Now moving on to question number 3. A ray of light is incident normally on a plain glass slab. What will be the angle of refraction and angle of deviation of the ray? So question number 3, for normal incidence, you know, air, glass, a ray of light passes undeviated. All of you know it. For normal incidence, what is the angle of incidence? Angle of incidence is always 0. What is angle of refraction? Since there is no deviation, angle of refraction, obviously it is 0. Clear? So these are conceptual questions. Question number 3. So question number 3 is over. Now moving on to question number 4. An obliquely incident light ray bends at the surface due to change in speed when passing from one medium to another. The ray does not bend when it is incident normally. Will the ray have different speed in other medium? Question number 4. So for normal incident, the case of normal incidence, look at the case of normal incidence. Air, glass passes undeviated. Why it is passing undeviated? Will it suffer refraction? There is any change in speed of light? Of course there is refraction when it travels from air to glass, but refraction is taking place in any direction, as I have mentioned in one of my video. So light ray can get deviated in any direction. We don't know in which direction the light rays get deviated or refracted. So for our convenience, in order to avoid confusion, we consider that the ray of light passes undeviated. So it is suffering refraction for normal incidence, and since there is refraction, of course there is change in speed of light. So the answer is yes, there is change in speed of light. Clear? Okay. So remember that for even normal incident there is refraction. Refraction can be in any direction. We don't know the direction. So in order to avoid confusion, we consider a straight path of the light ray. Alright? Okay. Now moving on to question number 4. 4 is over. Question number 5. What is the cause of refraction? What is the cause of refraction when it passes from one medium to another medium? All of you know the basic cause of refraction. What is the basic cause of refraction? Of course, the change in speed of light. The basic cause of refraction of light is change in speed of light. As you know, when a ray of light traveling from rarer medium to denser medium, it slows down. And when a ray of light traveling from denser medium to rarer medium, it speeds up. So the basic cause of refraction of light is change in speed of light. So question number 5 is over. Question number 6. A ray of light suffers reflection and refraction at the boundary in passing from air to water. Draw a neat labeled diagram to show it. So we have to show the refraction. So first we have to mark the boundary between air and water. Here the case is air and water. So we have drawn the boundary. A ray of light suffers reflection and refraction. So a ray of light incidenting at the boundary between air and water. So as you know that when a ray of light is incidenting at the boundary between air and water, it is partly reflected back to same medium, and it is partly refracted. Okay, draw a normal, and the refracted ray is bending towards the normal. Okay, so PQ is the incident ray, QR is the refracted ray, angle R is the angle of refraction, and angle I is the angle of incidence between the normal n dash and the incident ray, and it is being partly reflected. Some part, almost 4% of the light is reflected back. This is angle of reflection. All right, and maximum light is being refracted, and the refracted ray is bending towards the normal. Clear? Okay. Now question number 7. Moving on to the question number 7. A ray of light passes from medium 1 to medium 2. Which of the following quantities of refracted ray will differ from that of the incident ray? A ray of light is moving from medium 1 to medium 2. The same case, medium 1 to medium 2. You know the main quantities associated with a ray of light, that is speed, intensity, and wavelength and frequency. So as you know, we have already discussed, when a ray of light passes from one medium to another medium, except frequency, all other quantities such as speed, intensity, and wavelength change. So frequency remains unaffected because frequency is the characteristic property of the source from which the light is coming. So I can write which of the following quantities of refracted ray will differ from that of the incident ray: speed, intensity, frequency, and wavelength. So I can write speed changes, intensity changes, and even wavelength also changes. Okay, these three quantities change, but frequency remain unaffected because frequency is the characteristic property of the source of light from which the light is coming. Okay, yes. Now question number 8. What is question number 8? State the Snell's law of refraction of light. I have to state the Snell's law. So the Snell's law, according to Snell's law, the refractive index of a medium is the ratio of sine of angle of incidence to the sine of angle of refraction, sine I upon sine R. So that is the refractive index. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant quantity for that pair of media. That constant quantity is known as refractive index. You have to write mu is refractive index. Okay? Yes. Now question number 9. Question number 9. Define the term refractive index of a medium. Can it be less than 1? You have to give the definition of refractive index. What is refractive index? Refractive index is the light bending capacity of a medium. Mathematically, how will you express it? Refractive index is defined as the ratio between sine of angle of incidence in the rarer medium to the sine of angle of refraction in the denser medium is a constant for that pair of media that is known as refractive index. So you can write the meaning of refractive index, light bending capacity, and you can define refractive index in terms of Snell's law. All right? Okay. Now question number 9. Can it be less than 1? Can the refractive index be less than 1? Is it possible? No. Refractive index cannot be less than 1 because the speed of light is maximum in air or in vacuum. So when a speed of light enters into any other medium, it always decreases. The speed decreases. So the refractive index of any transparent medium is greater than 1. So refractive index of a transparent medium can never be less than 1 because what is the reason? The speed of light in vacuum is maximum. When it enters into any other transparent medium, its speed decreases. Okay? The reason is clear to you? Alright. Now question number 10. Moving on to question number 10. What is question number 10? Compare the speed of light of wavelength 400 angstrom unit, that is violet light, and speed of red light, that is 800 angstrom. You have to compare the speed of light, speed of violet and speed of red in vacuum. So light is a bundle of 7 colors or 7 wavelength, you know it. The speed of all the colors is same in vacuum. So the white light travels with a speed of 3 into 10 to the power. What is the speed of light? 3 into 10 to the power 8 meter per second. Alright. So it is same. The speed of light is same for all the wavelength in vacuum or in air. So I can write V violet to ratio V red is equal to 1 ratio 1. The speed for all the wavelength it is same in vacuum or in air. Alright. So these are the 10 questions which I have discussed from exercise 4A. I hope it is clear to you. Thanks for watching.